For centuries, humanity has gazed up at the stars, dreaming of other worlds. Among the celestial tapestry, one planet has captured our imagination like no other: Mars. Our celestial neighbor, the red planet, has long been a source of fascination and speculation. Ancient civilizations observed its reddish glow, weaving tales of gods and war. Today, powerful telescopes reveal a world of stark beauty, with towering volcanoes, vast canyons, and polar ice caps. Is this distant world destined to be more than just a celestial neighbor? Could it be our future home? The idea of humans on Mars, once confined to the pages of science fiction, is now a topic of serious scientific discussion. Pioneering organizations like NASA and SpaceX are actively pursuing ambitious plans for human missions to Mars, pushing the boundaries of space exploration. These plans are not merely flights of fancy, but are grounded in cutting-edge technology and a deep understanding of the challenges ahead. This is not just about planting a flag, it's about establishing a permanent human presence beyond Earth. The question is no longer if, but when and how. The journey to Mars will be fraught with challenges, a testament to human ingenuity and resilience. Mars presents a harsh and unforgiving environment. Its thin atmosphere, lack of a global magnetic field, and extreme temperatures pose significant obstacles to human survival. Yet, the allure of Mars is undeniable. The discovery of water ice on Mars has fueled hopes of finding resources vital for human life. The potential for in situ resource utilization, where we use Martian resources to sustain ourselves, offers a glimpse into a future where humans can thrive on another planet. When considering a new home for humanity, proximity matters. In the vast expanse of our solar system, Mars stands out as a remarkably close neighbor. It is the closest planet that offers even a semblance of Earth-like conditions. While the distance between Earth and Mars varies depending on their orbits, it is on average a mere 225 million kilometers, or 140 million miles. This might seem like an immense gulf to cross, but compared to the billions of kilometers that separate us from other potentially habitable worlds, it's a relatively short hop. Current propulsion technology allows us to envision journeys to Mars lasting between 6 to 9 months, a time frame that, while lengthy, is within the realm of human endurance. This makes Mars reachable with today's technology, a crucial factor when considering the logistics and feasibility of establishing a human presence. One of the most intriguing aspects of Mars is its similarity to Earth in terms of its day and year cycles. A Martian day, known as a sol, lasts 24 hours and 39 minutes. Imagine waking up to the familiar cycle of day and night, albeit under a salmon-colored sky. A Martian year lasts 687 Earth days. The presence of water ice on Mars fuels hopes of transforming it into a habitable world. For a Martian colony to be sustainable, it must be able to utilize the resources available on the planet. This is where the concept of in situ resource utilization, or ISRU, comes into play. ISRU is not just a logistical advantage, it's a necessity for long-term human presence on Mars. Mars's thin atmosphere, while a challenge for breathing, is composed primarily of carbon dioxide. This CO2, abundant in the Martian atmosphere, could be a valuable resource. It can be broken down to produce oxygen for breathing and even used as a propellant for rockets. Furthermore, the Martian soil, known as regolith, could be used as a building material. 3D printing technology could be employed to create habitats and structures from regolith, reducing our reliance on materials transported from Earth. The challenges of Martian life are undeniable, but so too is the ingenuity of the human spirit. As we continue to explore and understand Mars, the dream of making it our second home becomes less a question of if and more a matter of when and how. While the allure of Mars is strong, the red planet presents significant challenges to human habitation. One of the most pressing concerns is the high level of radiation that bombards the Martian surface. Unlike Earth, Mars lacks a global magnetic field, exposing it to harmful cosmic rays and solar radiation. This means Mars is constantly exposed to high-energy particles from the sun and deep space. These particles can penetrate human tissue, damaging DNA, and increasing the risk of cancer. Another hurdle in making Mars habitable is its extremely thin atmosphere. Composed mainly of carbon dioxide, the Martian atmosphere is about 100 times thinner than Earth's. This thin veil of gas provides little protection from meteoroids and makes breathing impossible without specialized equipment. On Earth, our atmosphere acts as a protective blanket, regulating temperature and shielding us from harmful UV radiation. Mars's thin atmosphere offers little such protection. The lack of atmospheric pressure means liquid water cannot exist on the surface for extended periods. The implications for human survival are clear. Creating a breathable atmosphere on Mars is a monumental challenge. Mars is a planet of extremes, and its temperature swings are no exception. With an average surface temperature of -60 degrees Celsius or -80 degrees Fahrenheit, Mars is far colder than even the most frigid places on Earth. These extreme temperatures are a direct result of Mars's thin atmosphere, which is unable to retain heat from the sun. While temperatures near the equator can reach a balmy 20 degrees Celsius or 70 degrees Fahrenheit during the day, they plummet to a bone-chilling -73 degrees Celsius or -100 degrees Fahrenheit at night. These drastic temperature fluctuations pose significant challenges for human habitation, requiring specially designed habitats and energy-efficient heating systems. The extreme cold also affects the availability of liquid water. While water ice exists on Mars, it is often locked away beneath the surface or in the polar ice caps. Melting this ice and keeping it in a liquid state requires a significant amount of energy and careful management of resources. While the images of towering volcanoes and vast canyons on Mars are captivating, a significant challenge for human habitation lies in the planet's low gravity. With only about 38% of Earth's gravity, Mars exerts a weaker gravitational pull. This affects the human body significantly. Imagine jumping higher and lifting heavier objects with ease. However, the long-term effects on health are concerning. Prolonged low-gravity exposure leads to muscle atrophy and bone density loss. Studies show astronauts experience up to 2% bone loss per month. This rate exceeds osteoporosis on Earth. Muscle mass deteriorates rapidly without Earth's gravity. Mars's gravity is stronger than in orbit but still lower than Earth's. Mitigating these impacts on human physiology is crucial. As we grapple with the challenges of making Mars habitable, a more ambitious question arises: can we terraform Mars? Terraforming, the hypothetical process of transforming a planet's environment to make it more Earth-like, has captured the imagination of scientists and science fiction writers alike. Imagine a future Mars with flowing rivers, lush vegetation, and a breathable atmosphere. While this vision may seem like science fiction, some scientists believe that terraforming Mars, while incredibly challenging, is not entirely outside the realm of possibility. Proposed methods for terraforming Mars range from releasing greenhouse gases trapped in the Martian soil to strategically directing asteroids to impact the planet, releasing heat and volatile compounds. These ideas are still largely theoretical, and the technological hurdles are immense. A key challenge is the lack of a global magnetic field on Mars. Without this protective shield, any atmosphere we create could be stripped away by the solar wind, rendering our efforts futile. Furthermore, the ethical implications of altering an entire planet to suit our needs are profound and require careful consideration. Protecting future Martian colonists from relentless radiation is crucial. Mars lacks a global magnetic field, necessitating innovative shielding solutions. Constructing habitats with Martian regolith is a promising approach. Compacted regolith acts as a natural radiation shield. Building underground offers natural protection from radiation. Lava tubes provide ready-made underground shelters. Active shielding technologies like localized magnetic fields are also being explored. Effective radiation countermeasures are vital for future Martian settlers. The thin Martian atmosphere presents a formidable obstacle to human habitation. Innovative solutions are needed to provide breathable air and protection. Enclosed ecosystems like biodomes are one approach. Plants convert carbon dioxide into oxygen through photosynthesis. Biodomes provide oxygen and food for colonists. NASA's MOXIE has shown oxygen extraction from the Martian atmosphere is feasible. Scaling up MOXIE could supply breathable oxygen for settlements. Engineering habitable environments on Mars is no small feat, especially when it comes to conquering Martian temperatures. The extreme temperature fluctuations on Mars pose a significant challenge for human habitation. One approach is to design habitats with advanced thermal insulation. Solar energy could be harnessed to power heating systems. Another strategy involves exploring geothermal energy sources on Mars. Defying gravity's grip on Mars is another critical aspect of Martian habitation. Mars's lower gravity, while offering the allure of superhuman leaps and lighter loads, presents a significant challenge to human health, demanding innovative solutions to mitigate the long-term effects of living in a reduced gravity environment. One proposed solution is to create artificial gravity within Martian habitats. This could be achieved by constructing rotating structures, where centrifugal force mimics the effects of gravity. The larger the rotating structure, the more closely the artificial gravity would resemble Earth's, reducing the adverse effects on human physiology. Another approach is to develop advanced exercise regimens and equipment specifically designed for the Martian environment. Regular exercise, particularly resistance training, can help maintain muscle mass and bone density, counteracting the detrimental effects of low gravity. Virtual reality technologies could also play a role in mitigating the psychological effects of living in a low-gravity environment. VR simulations could provide immersive experiences of Earth-like gravity, helping to reduce feelings of isolation and disorientation. Can we terraform Mars? Transforming an entire planet to suit our needs seems like science fiction. Terraforming is about reshaping a hostile planet into a world more like Earth, engineering a second home for humanity. Imagine humans walking freely under a blue sky on Mars. The path to terraforming Mars is complex. Section 2. The Atmosphere Enigma: Thickening the Martian Air. Transforming Mars' thin, unbreathable atmosphere is crucial for human life. Mars' atmosphere is mostly carbon dioxide, about 100 times thinner than Earth's. Releasing greenhouse gases from polar ice caps could thicken the atmosphere. These gases could trap more heat, warming the planet gradually. Introducing super greenhouse gases is another approach, but it carries risks. Mars lacks a global magnetic field, making it vulnerable to solar wind. Without protection, the solar wind could strip away the atmosphere. Section 3. Ethical Crossroads: The Dilemma of Planetary Engineering. The prospect of terraforming Mars raises profound ethical questions. Do we have the right to alter another planet to suit our needs? Some argue it's a natural progression of human exploration, ensuring our survival and expanding our reach. They see Mars as a blank canvas for humanity's future. Others worry about the ecological and ethical implications. What if Mars harbors life forms we haven't discovered? Would terraforming be a cosmic act of vandalism? The ethical dilemma extends beyond Martian life. Should resources for terraforming address Earth's pressing problems instead? Advancements in spacecraft technology. The dream of reaching Mars has fueled a surge in spacecraft innovation. Private companies like SpaceX and government agencies like NASA are developing next-gen spacecraft. SpaceX's Starship aims to carry up to 100 passengers to Mars. Starship's reusability could reduce spaceflight costs and make Mars missions more frequent. Its Raptor engines are designed for both Earth and Mars landings. This reusability is key to sustainable Mars colonization. NASA's SLS will transport infrastructure for future Martian outposts. These advancements are paving the way for human exploration beyond Earth. For a Martian colony to be sustainable, it must utilize the resources available on the red planet. In situ resource utilization, or ISRU, drives innovation in resource extraction and life support systems. Water ice, abundant beneath the surface and within the polar ice caps, is crucial. Extracting and converting this ice into usable water is a top priority. NASA's Perseverance rover carries MOXIE, producing oxygen from the Martian atmosphere. MOXIE extracts oxygen atoms from carbon dioxide, generating breathable air. ISRU research also focuses on utilizing Martian regolith for construction. Regolith could be used as a building material, potentially with 3D printing. Constructing habitats and infrastructure on Mars presents a unique set of challenges, requiring innovative approaches to construction and resource management. Traditional construction methods, reliant on heavy machinery and abundant materials, are impractical for a Martian colony, necessitating a shift towards lightweight, adaptable, and resource-efficient solutions. One promising technology is 3D printing, also known as additive manufacturing, which involves building structures layer by layer from a digital model. 3D printing on Mars could utilize regolith as a primary building material, significantly reducing the need to transport materials from Earth. Imagine robotic 3D printers powered by solar energy, autonomously constructing habitats and other structures from Martian regolith. These structures could be designed to withstand the harsh Martian environment, providing protection from radiation, extreme temperatures, and the thin atmosphere. The prospect of Mars becoming humanity's future home is both tantalizing and daunting. The red planet, once a distant world observed through telescopes, is now within our reach, thanks to advancements in space exploration technology and our relentless thirst for knowledge. However, the journey to Mars is not merely about overcoming the vast distances that separate our two worlds. It's about confronting the formidable challenges that Mars presents, from the thin, unbreathable atmosphere to the constant threat of radiation, from the extreme temperature fluctuations to the long-term effects of low gravity on the human body. These challenges are not insurmountable, but they demand innovative solutions, a willingness to adapt, and a deep understanding of the red planet's secrets. The question of whether Mars will become humanity's future home is not a simple yes or no. It's a complex equation with many variables, some of which we are only beginning to understand. It's a balancing act between our aspirations for a multiplanetary future and the realities of surviving in a hostile and unforgiving environment. The pursuit of Mars is more than just a scientific endeavor. It's a testament to the indomitable spirit of exploration. It's about pushing the boundaries of human ingenuity and seeking answers to fundamental questions. The challenges of Mars are real, but so too are the potential rewards. The knowledge gained will lead to technological breakthroughs and scientific discoveries. The journey to Mars requires courage, collaboration, and belief in human ingenuity. If we succeed, it will be a testament to the boundless potential of our species. The red planet beckons as a stepping stone on humanity's next giant leap. Thank you for watching. If you find this video interesting, please press the like button, leave a comment, and subscribe to our channel.